Hello everyone, I welcome you all to today's session wherein we are going to discuss one more question from the CAT level difficulty questions. So I bring questions from different areas, right, of your preparation, from areas like geometry, from areas like logarithms, from areas like progressions. So today we have a question from the coordinate geometry, right? Graphs you may say, or coordinate geometry as well. You can pause the video and try out this question once yourself, and then we shall start the discussion. I will anyways be starting the discussion here, right? Let's start with it. It says find the length of the perpendicular drawn from -1, 2. The point -1, 2 on the graph, if you look at it, is going to be somewhere out here, right? Somewhere like this, -1, 2. From this point, we are drawing a perpendicular on this graph, right? Y equal to mod of x plus 2 minus mod of x minus 2. Now, what can we say about mod of x plus 2 minus mod of x minus 2? Let's try to observe. Let's try to plot it. Mod of x plus 2 minus mod of x minus 2. So, if I take the value of this particular graph, right, the value of y for this particular graph for values of x greater than or equal to 2. So, if I take greater than or equal to 2, let's see what happens. First case. So, if I put x is greater than or equal to 2, because see there are two kind of zeros that we have here, right, where the mod will change its value. One is x equal to 2, other is x equal to minus 2. Right? So, let's take x equal to 2 case. So, x greater than or equal to 2, both the modulus, the terms inside the modulus will end being positive. Hence, can I say in that case y will be, this will be simply x plus 2, this will be simply x minus 2, which will give you what? X will cancel out. 2 minus of minus 2 will be 4. So that means for any value of x greater than or equal to 2, let me just draw the graph again properly. For any value of x greater than or equal to 2, let's say 2 is here. And the point that we had was here, -1, 2. So for any value of x greater than or equal to 2, the value of y is going to be 4. Okay, so the graph will be like this. The graph shall be here, x equal to 2 or greater, y is 4. It's like a horizontal line. Next, for any value of x in between -2 and +2. So if I take x greater than or equal to -2, let me do one thing, let me write it on the next slide. Second case, if I take x greater than or equal to -2 but less than 2. So in this case, please understand, this modulus term will turn negative. X minus 2 is going to be less than 0, whereas this is going to be still positive. So in such a case, y is going to be mod of x plus 2 is going to be x plus 2 only, minus x minus 2 is going to change its sign. It's going to be negative. X minus 2 is going to be negative. So thus minus mod of x minus 2 will become minus of x minus 2. So minus and minus will become plus here. You can write this x minus 2. So it's going to be y is equal to 2x. So in this range, -2 to 2, the graph will be y equal to 2x line. So -2 to 2 would mean somewhere here, right? -2, 0. Between x equal to 2 and x equal to -2, the graph is y equal to 2x. So graph y equal to 2x shall be like this. So it is going to be, this is 4. Okay, this is 0, 4 point. It's cutting at y-axis. Similarly, it would be at here, somewhere here. This will be 0, -1. And the line in between this -2 and +2, y equal to 2x line, shall be like this. It passes through the origin. It's going to be like this. Okay. Next, for the third region, which is x less than -2, both the modulus will turn negative. So y will, in this case, will be, this is minus of x plus 2, This is minus of minus plus x minus 2. So this is going to be what? Minus x plus x cancels out. Minus 4 it is. So y equal to minus 4, constant value. So that means for any value of x less than minus 2, the graph is going to be a horizontal line again. So ultimately the graph shall look like this, right? And the question was about finding the perpendicular, the length of the perpendicular drawn on this particular graph. So from this point, when you drop a perpendicular, please notice the perpendicular shall be as follows, somewhat like this. It shall be like this. So when you drop the perpendicular like this, he's asking us the length of this perpendicular. How do we find it out? In coordinate geometry, we have a formula. The formula goes like this. The length of the perpendicular is nothing but mod of ax1 plus by1 plus c by root over a square plus b square, where the point we are talking about is x1 comma y1 and the line we are talking about is ax plus by plus c equal to 0. In the present case, please notice the line that we have is y equal to 2x or 2x minus y equal to 0 and the point we have is minus 1 comma 2. So what's the distance L? L will be nothing but, if I apply the formula, mod of 2x1 minus y, which is 2, by root over 2 square plus 1 square, which is root 5. So it's going to be minus 2 minus 2, 4, since there is a mod, 4 by root 5. So this length out here is going to be 4 upon root 5, and this is going to be our answer. Because when you drop the perpendicular, it would be proper perpendicular to the graph only here. It cannot be a perpendicular here or to the above region, right? We cannot have a perpendicular here like this. Because when you drop a perpendicular from here, it will go like this. It won't meet the graph, right? Similarly here, it won't go meet the graph. So there is only one perpendicular, thus option choice D is going to be the correct answer. So a similar question has been asked in CAT in the previous years, right? So over there, plotting the graph, right? Plotting the graph, or at least thinking about how the graph would look like, right? There is no need to plot it like this, but at least knowing that, okay, for any value greater than or equal to 2, y is going to be 4, it's going to be 2x in this range, it's going to be minus 4 in this range. Knowing that much is essential, right? And only then I can, and also this formula, which I am sure we are all aware of. So I hope you have followed this question. So with this, we have come to the end of the session here. Thank you and all the very best.